All right, we're going to talk about graphing linear equations and inequalities. So you should have done this in one of your previous math classes, but we're going to talk about it as if you've never done it before. So when we're graphing linear equations or inequality, the function must be written in slope-intercept form, okay? So hopefully you're going to remember that it's going to be in slope-intercept form. Now, what is slope-intercept form? Y equals mx plus b, where m is our slope, and that's rise over run. So if you remember, you go up and then, or down, and then left or right. And then our b is our y-intercept. And if you remember, our y-intercept is the point 0, comma, y. Anytime we know our y-intercept, x is always 0. Now, speaking of x and y, if you remember on the graph, it's x, comma, y for an ordered pair. You graph and go left or right first, and then up or down. Okay, so let's go down and look at our problem here. So we're going to graph the linear equation here, 6x plus 3y equals 9. Okay, before I can graph this, I need to solve for y. I need to put it in y equals mx plus b. Okay, so I'm going to subtract 6x. And I get 3y equals negative 6x plus 9. Then I'm going to divide by 3. Hopefully you've been practicing those equations. So y equals negative 2x plus 3. Okay, so now I have it in slope-intercept form, y equals mx plus b. So I need to find out what my slope is. So my slope is negative 2. So if I'm doing rise over run, it could be negative 2 over 1, or it could be 2 over negative 1. So remember, I could go down and right, or I can go up and left, because left is negative and down is negative. Okay, my b equals 3, so that means I'm going to start at the ordered pair 0, comma 3. So here I am at 0. I'm not going left or right because x is 0. I'm just going up 3. That's going to be my first and my starting point. This is the y-axis. The y-intercept will always lie on the y-axis. Okay, negative 2 over 1, that would be down 2, right 1. And then 2 over 1 could be up 2, left 1. Now I can't go up anymore, but if I wanted a few more points, I could go down 2 again and right 1. Okay, so let's grab a line up here. So you want to extend your line past the points, and then this line does not stop just because this graph starts, so we want to put arrows on our line. So that is how we're going to do those graphs. So you should try to get a straight edge. You can use the side of your calculator or notebook and make your line straight. All right, so let's remember if y equals 2, okay, so when y equals 2, that is a horizontal line. Okay, that goes left or right. So let's talk about y. If we do a t-chart, y equals 2. So y, no matter what x is going to equal 2. So we could say x is 0, x is 1, x is 2. We could go negative. So at 0, y is going to be 2. At 1, y is going to be 2. At 2, y is going to be 2. At negative 1, y is going to be 2. So no matter which way I go, y is always going to be 2. So it's going to make that horizontal line. So let's grab our line. And again, this line does not end where our graph ends, so we're going to put our lines there. All right, so if this one's horizontal, x equals is our vertical line. Okay, think about a vertical jump in basketball. That means it's going up or down. Think about the horizon for the sun. Horizon's left or right. Okay, so here, anytime we go anywhere, x is always 3. So it could be 3, and y could be 1, y could be 2, y could be 3. So we're going to go over where x is 3, 1, 2, 3. Okay, there's a point, there's a point. Look, it's intersecting there. We're going to be talking about intersecting lines later. All righty, so let's grab our line. You're grabbing your straight edge. And then remember, our line does not end just because our graph does. So arrows showing that continues. Okay, so you'll be practicing that. Please let me know if you have questions on those. Okay, so graphing inequalities. You're going to solve for y first if it's not already done so. Just like with equations, you're going to graph slope and y-intercept, just like with equation. Then you're going to ask yourself, am I going to have a solid line or a dashed line? Am I going to shade? Oh, yes, we have to shade above the line or below the line. So let's talk about what happens. There are two things to consider when graphing. So line type. If it's a solid line, that means it's equal to, and all the values on that line are included. So that's going to be greater than or equal to, less than or equal to. The key thing with solid is the equal to. If it's a dashed line, it's going to be greater than or less than, but not equal to. Okay, so I always start my problem asking solid or dash, above or below. Okay, so let's move on down. Shading. When you shade below something, if something is below, we think of less than. Okay, you should anyway. So it could be less than or equal to, or it could just be less than, because that's below. If things are above, like above 0, different things like that, then we think of greater than or equal to. So that's our shading. Okay, so let's look at an example. So here, this is already solved for y. If not, you would solve for y just like we do in the equations, and then we're going to talk about our slope. So our slope here is 2. Now, speaking of slope, since this is a positive slope, I know immediately my line is going to slant to the right. Now, my y-intercept is 0, 2. All right, so is this, so we got that. So now we have less than, and it's not equal to. So that means since it is less than, I'm going to have below shading, shade below the line. And then since it is not equal to, I'm going to have a dashed line. All right, so we're going to go over here to 0. We're going to go up to 2. And then the slope is 2. So 1, 2 over right 1, down to left 1. Okay, notice my line is slanting to the right. Let's see, I need a dash line. I think this one will give us, nope. Let's undo that. Here we go. Sorry, trying to find this. All right, dash line. Okie dokie, and then we're going to put our arrows because again, it continues. And shade below. Is this side above or is this side above? This is above, so this would be below. So we're going to shade below, and I'm going to make it into a highlighter so mine will shade quicker. So we're going to shade below the line. Now, if you don't know which way is below, you can always do a test point, okay? And normally my test point I use is 0, 0. So let's look at how the test point would work, okay? So here it's 0, 0. I need to know if this is true or not. So I take my function and I plug in the points 0, 0. So I'm going to plug in 0 for y and 0 for x. Okay, so 0, 2 times 0, 0 plus 2. Is 0 less than 2? Yes. So that means I would shade. Okay, we'll look at another one in just a second. Okay, so here's this one. So my slope here is 1/2, and my y-intercept is 0, -1. This one is greater than or equal to, so I'm going to have a solid line. And since it's greater than, it's going to be above, shaded above. Okay, so let's start 0, -1. Don't forget this negative goes with that 1. So 0, -1. Slope is 1/2, up 1 over 2, up 1 over 2. Or if I needed to, I could go down because that's negative and left because a negative divided by negative is a positive. Okay, this one is a solid line. Oops, got to change it back. All right, so this one is going to be a solid line. Let me see if I can get that a little straighter. I'm having a hard time with my lines, guys. Calm down. Oh, goodness. How did I get a curved one? There we go. Okay, and again, I am going to put arrows on both ends and be ready for that. Now, let's look at our test point 0, 0. Okay, if I plug that in, I have 0 is greater than or equal to 1/2 times 0 minus 1. So that would be 0 is greater or equal, that's 0 minus 1 is -1. Is 0 greater than or equal to -1? Yes. So that means I'm going to shade above. And is that what I was supposed to do? Yes. Okay, so let's change my pen here to a highlighter. And let's just highlight above that line. Okay, so you're going to highlight. Now, what is the difference between a solid line and a dashed line? So in this case, it includes all the answers. If I pick any ordered pair in this shaded, it will make this statement true. I can also pick anything that lies on this line. Whereas the dashed line, if it was something that lied on this line, it would not be true. So it would not be because it would end up being equal. Okay, so that is the difference. Now, what is the solution to this? You know how normally we have like x equals 5, x equals 10. Well, the solution to these are any ordered pair in the shaded area. So I could have 0, 1. I could have 1, 1. I could have 2, 1. I could have 1, 1, 2, 3. And if I plug all of those in, it's going to make that statement true. So all of these, it has tons of answers instead of just one equals. All right,